Okay, so we've finished the pictorials, so the 3D drawings that we did when we covered perspectives, covered isometrics, and we covered obliques. Now we're going to start talking about multi-view sketches, and multi-views that are not three-dimensional. So these are going to be two-dimensional drawings of how we see the different sides of an object. So a multi-view drawing will show two or more sides of a three-dimensional object. The multiview provides the shape description for that object, meaning I identify the contour. And when we combine the multiview drawing with dimensions, it serves as the main form of communication between the designer of a product or object and the person who's going to be manufacturing that for us. So this would be an example then. If I'm the designer of the chair, I'm going to provide the different views of that chair. This is a multi-view drawing, along with the pictorial to show what these would look like three-dimensionally. So this is my isometric view of that chair. We would need dimensions if we wanted to build this. So that would be included on the drawing as well. So this would be more common in the type of multi-view drawing that we would do. Right? This is a geometric shape or geometric object. I would do a layout of the top, the front, and the right view of this object, and then add dimensions as a way of communicating the sizes for the different parts of that object. So all three-dimensional objects have width, height, and depth. So I can describe the size of the object using the terms width, height, and depth. The width is associated with the object's side-to-side dimension. So if I'm looking at the front of the object, from the right side to the left side of that object would be considered the width. The height is from the object's top to bottom dimension or distance, and the depth is associated with the object's front to back. And so the front of the object to the back is the depth for an object. If this is the object that we were creating a multi-view drawing for, my top view would be the view of me looking directly down on this object. So a perpendicular view of this object looking directly down. This would be what I see from the top. If I were to take that object then and rotate it 90 degrees, I get what I would see from the front of the object. So my view looking directly at the front, and then rotate it again, I get the right view. Okay? Because these drawings are based on the same object, they share the same height, width, and depth. So what I mean by that is the front view of the object and the right view of the object share the same height. If I were to measure the distance between here and here on my front view, I could simply pull this line across, and that's exactly where that measurement would be on the other view. Okay? My top and my front share the same width, and then my top and my right share the same depth. So every view has one measurement in common with the other two views. So we're going to talk about orthographic projection as the technique for creating a multi-view drawing. Right? The training wheel is the simplest way to start or think about this process. Okay? The idea is that any projection of the features of an object onto an imaginary plane is our orthographic projection. The projection of the features of the object made by lines of sight that are perpendicular to the planar feature. So when I draw a multi-view drawing, I'm looking at that surface and I'm not considering depth, just what I would see if I were looking directly at it at a 90-degree angle. Okay. So we're going to use the orthographic projection with what's called a glass box to create our drawings. Okay, we've talked about glass boxes for doing some more pictorials. Today in our activity we'll make a physical glass box that we can put our objects in. Okay. So the glass box has 6 sides. My object has 6 sides. If I place the object within the box, the idea is now I'm going to look at each of the sides and project out what I see onto my box. Okay. So we're going to refer to this as a plane of projection or picture plane. It's the imaginary surface that exists between the view and the object. In our case, it'll be basically the edge of our glass box. And it's the surface onto which a two-dimensional view of a three-dimensional object is projected and created. So the edge of my box then is my projection plane. If I'm looking directly at this surface with a line of sight that's 90 degrees, I would see each of these 5 corners of that object. The idea then is that I would project out from those corners, basically lines that would touch my projection plane, and then each of those points can then be connected to complete the drawing. So I'm going to connect each of these, and that basically outlines the surface that I see for that object. And that's overly simplified, because some of you would probably be able to draw this just by seeing what's on that surface. But this is the process of what's happening as we're doing this here. This would get repeated for all 6 sides of the object. And then I would have basically the layout of all 6 views. So if I were to take that glass box back apart, which we'll talk about in today's activity, I would see all 6 views of the object. Okay. If this were the object I were drawing, here's my top, front, right view, bottom, rear, and left. It would be rare that we would do a multi-view drawing that has all 6 views on it, because a lot of this information is repeated. Notice that the left view and the right view look very similar, other than the fact that we have hidden lines here. We'll discuss what those mean in just a minute. So a lot of multi-view drawings will simply have 3 views, because it would be enough information from here for someone to be able to create or manufacture this for me. Okay. So when I'm placing the object in that box, I do need to identify the proper front view for that object. And I know we talked about this several times. And again, here's the criteria. Most natural position, shows best shape and characteristic contours, longest dimensions, fewest hidden lines, and most stable and natural position. And again, we've used this example before. If this were the object, identified this view, meaning I would be looking perpendicular to this view, as my front view because of the fact that it meets the criteria that we listed out. So when I start thinking about the number of views I need to create a multi-view drawing, there are circumstances where 6 views is too many. Repeated information like we saw on the previous slide. Most of our multi-view drawings are probably going to have 3 views, but there are some that could be 1 or 2 view drawings, and we'll talk about which ones those would be. So if I have an object that has uniform thickness or shape, meaning that it's the same thickness throughout the entire object, where a second view for that object would be identical to one of the other views, and all dimensions properly and easily shown on that view, then we could get away with a 1-view multi-view drawing. Technically, it's not multi-view, but it would still be called that. If I have a circumstance where I'm using a symmetrical part that I'm creating the multi-view drawing for, and a third view would be identical to one of the other views, second view is necessary just to show the depth, then I would probably be able to get away with a 2-view multi-view drawing. If it doesn't meet either the criteria for this or the previous one, then typically our standard is going to be 3 views: top view, front view, and right view for that object. Okay. So given the overall dimensions of an object and a sheet of graph paper, we're going to sketch out a multi-view drawing using points, construction lines, and object lines. Again, our construction lines in this PowerPoint will be red. We're going to keep them as light as possible, like we did in our pictorials, because it won't be part of the final drawing. So this is basically the multi-view, and we're going to go through the steps of how we would create that. First, I want to lay out the boxes within which the individual views will occur using points and construction lines. So I'm using red as my construction lines, and I'm laying out in the proper orientation the space that would be needed for each of the views. So the overall width here for where my front view is going to go is based on the dimension for this line here. That's the width of my object. The overall height for the front view is based on the overall height of my object here. And I use the same dimensions for the other views. Okay, so what's kind of shaded in here is where I'm going to place my top, my front, and my right view for this object. The reason we are leaving space in between is eventually we would be adding dimensions, and we need room to do that. Okay, so we're going to leave space in between our views so that in the future we can add dimensions. Okay. The orientation is always going to be top, front, right view. It's always going to be in this orientation, so we simply need to memorize that. Now I'm going to use construction lines to lay out the different details of this object. Like my front view is an L shape. I need to know where this measurement is and where that are, and I place this on the drawing here. Okay. So this line represented here, and I'm pulling across to both views, because remember we talked about them sharing the same height. It would be the same on both views. I don't need to measure a second time. Then I need to darken in using object line the visible edges of my object. In this case, there's quite a few here. Last step is to identify hidden lines within our object. And we haven't used hidden lines before. We used construction lines and we use object lines. A hidden line is a line that's drawn as short dashes, and it represents information on a view that cannot be seen from that view. What I mean by that is, if I'm drawing the front view, meaning I'm looking at the front and that's all I can see, I have no way of knowing that this portion has been cut out or that this portion has been cut out. So to show that on the front view, I would add hidden lines to represent there's information that can't be seen from this view. So when I look at the drawings here, I know that this is what's been cut out, which cannot be seen on my front view. I simply pull this line directly down and I'm going to draw dashed lines. Same with the right, this part has been cut out, dashed lines on my front view. So I'm drawing these dashed lines here to represent what can't be seen from that. All right, quick question, and this is a way to think about the importance of multi-view drawings and the number of views. Each of these blocks has the same overall dimension and color. What else do they have in common? Common answers would be tonal shading, that's correct. But if we're thinking about multi-views, and I were to draw the top view for each of these blocks, they would be identical. Right? The top view would look exactly the same for each of these, but I'm noticing that the shape is completely different, so obviously I would need more views to identify the actual shape of that object. Right? A front view would probably need it, maybe a third view in this case. So all of these objects share the same top view. Let's talk about today's activity. We're starting 2.3, which is the glass box activity. And we're actually going to build our glass box. So our goal is to be able to build one of these. We're going to start by using what's called a cube net. It's been printed out for you. Okay, there's a couple steps that we would go through to cut this out, fold the edges, but when we're done, we're going to get our actual cube. Okay, this is going to serve as the glass box for the object that we're going to draw today. Okay. I put just enough tape for this to hold together. I don't want to tape it down so much that I can't get everything back apart, because when we're done, we need to be able to unfold it again. You're also going to be using linking cubes. You'll have 6 cubes, and with those you'll design basically a puzzle cube piece that we'll put inside our glass box. So the design is going to be up to you. So let's say I'm using these linking cubes and I come up with a design. I need to identify the proper front view for this object, and we can go back and look at the criteria for that. And then I'm going to tape this into my box so that the front view is in the proper place. So each of these has a specific side. I want the front view in the proper place. I'm going to take that last side down so that I have my object within the glass box, and I'm going to use one of these dry erase markers to draw then what I see from each of the 6 views. Okay, so what I would see from each of those views I want to draw on this object. Now I know that these have like circles in them and I can see all the individual cubes. I want you to treat this as if it were a solid object. Right, so on the back here, I would outline the object. I don't have to show each individual cube or the circles within that cube. If there's anything that can't be seen from that view, make sure that you include the hidden lines on your drawing here. Once I've identified and drawn each of the 6 views, you're going to take the cube net apart, and then I want you to draw out, like we saw in the example, each of the 6 views of the object. So you may want to turn your notebook to the side so that it fits more of a landscape orientation, and draw top, front, right, your back, bottom, left, and identify each of those views. Once you've done that, you're going to go to question number 6, and it's asking you to exchange your puzzle cube piece, the piece that you design, exchange that with somebody else, and they are going to then draw the top, front, and right view of that piece. So you're not using a cube net. You can simply identify the proper front view, draw what I would see from the front, draw the top, draw the right. We're going to disregard the isometric views for here so that we don't have to use another sheet of iso paper for that. Just identifying the top, front, and right view of someone else's puzzle cube piece. And then questions 7 through 11 are having you draw the missing view. So in this case, I have the top view, I'm missing the front view, and I have the right view. I want to draw each of the 3 views in my notebook in this orientation. Right? The top always sits on top of the front view, the right is always to the right of the front view. So in this case, the front view is missing. I want to draw that. The next few might be different views. The front view missing on number 8. Number 9 is the right view that's missing. Right view for number 10, right view for 11. There are no dimensions given, but it doesn't necessarily matter. Draw these to a certain scale on the grid, and then use that same grid to complete the other parts of the drawing. So if the overall width of this ends up being 6 squares, I would use that information as I'm doing the other drawings. There are also conclusion questions on this. I want to make sure that you are answering those as well before you submit everything to the LMS. So we will have the glass box that you've made with the drawing. That drawing gets transferred to the notebook. You'll exchange your puzzle cube piece with somebody else so they can identify the 3 views of that object. There's a couple drawings where you're going to be identifying the missing view, drawing that in the notebook, and then the last step would be the conclusion question, and all of those will be submitted in on the LMS.